Hello everyone. Welcome to the stream where we do some FPV repairs, or we try to do some FPV repairs. I still have no idea what I'm doing, but I'll keep doing it until I run out of things to repair, which by the looks of it is going to be never. So for a quick reminder of all the things I have on all the boards and stuff I have to have a look at. We're only getting more of them every day. So we have this, which we kind of got down a bit. It's from a friend, and I'll send him back all the things so we can share the love of the repairing, the kind of deal I do where people send me boards and then I can buy it back for €5 to pay for parts. And I usually do it around myself, around like friends that I can hand the boards to, because I don't want to go and have to pay for shipping for something that might or might not work as well as it should. So that's eventually gonna go back to his side of the world, because his side of France, because he sent me a bunch of things so he can kind of share the repair stuff with people. We have a bunch of things that were given to me by Danza and also other people, Rimka, and a bunch of other people here. And then we have what we're going to be looking at today, which is a bunch of gear given me by Donéo, which is a friend from the team. So yeah, a bunch of flight controllers, ESCs, and then I have a bunch of other things, a bunch of sorted and unsorted bags and boxes of many things. So yeah, we're not running out of stuff anytime soon, but that's good. Hopefully everybody's settling in okay. As always, if you want to come to the voice chat and ask questions or just participate, you're absolutely welcome to do so. You can do that by joining the Discord that's linked in the description. And as long as you don't try to monopolize try to stay as long as you don't words are hard today, I'm sorry. Yeah, you're welcome to come and just keep it respectful, so you don't monopolize the voice chat, and we can still chat and talk about electronics repairs. You're absolutely welcome to come and have a chat. Obviously, if you prefer to watch the stream from your sofa or put it in the background while you take a nap, that's absolutely fine too. So yeah, that's as always, we're going to be looking at some boards. We'll probably going to be looking at this one first, which is one of the more recent board design from Flywoo. It's the Flywoo Goku. It's the white board. And I don't know what this one has, so I'm going to have to investigate. And I have donors for this, so I should be able to get the right parts. And then probably, depending on time, we probably try to do an ESC as well, so we can have a fully repaired stack go in the box. Everything on the box has pretty much gone recently, so people have been getting their spares and getting their repaired boards for their new builds or to replace some burnt electronics. So I need to keep going so we can keep the stash full and people happy. That's going to be the goal today. Get some 30 by 30 stuff fixed. I'm pretty much the only one in the group that flies 2020, so I'm not going to focus on 2020. My stuff's doing fine, so all right. Oh, something I wanted to talk to you about. I don't have it here. Last week, I repaired a Volterra ESC doing a pad repair. And I had the creator of the ESC on stream as well. If you're interested in seeing what it's like and how cool Liviu, who's the creator, is, I encourage you to go back and watch the VOD for that stream, last week's stream. But yeah, we had a bit of an anticlimactic end where I kept plugging the quad and sometimes it wouldn't start up correctly. It turns out it was a solder projection on the board, so I removed everything, still had the bug, cleaned it up, saw the small metal bit, so a small metal ball on the board. I removed it and it's been working fine. I flew it this weekend and it's been doing great. So yeah, so that was a successful repair. I'm a bit sad that we didn't get to see it fly on stream, but yeah, it's been working fine. So yeah, hi everyone who's in the chat. I have a quick look. So we have Ducky Productions who helped us recently last stream as well for fixing the ESC. That was really good. We have Clyde. Hi, Clyde. Mads, Feed, Pablo, everyone, all the good friends here for the stream. So that's really nice. Oh, that's my new meter beeping. I am in the progress of hooking up my new meter to the PC so I can show you the values on live stream. Didn't really have time today to set that up, but hopefully by next stream you should have the reading that I'm getting on the meter, which is this new thing. But in the meantime, we do have a stronger beep, so you should hear it better on the stream, at least when I do continuity check. But soon it's going to be displayed on the stream, and it's going to be better for you guys. Next, we'll be finding a way to show you the power supply, but I'm not exactly sure how I'm going to do that now because it's a good power supply. I don't want to change it yet, and it doesn't connect to the PC. All right. Let me put that away. And we're going to get started on this board. So let's see if we can go for the cleanest route to finding out what it has. So first thing, I'm going to see what happens when I plug the USB. And as someone raised last stream, the French stream, there is some risk in plugging in the USB to my laptop without checking anything.
Yeah.
Normally, the USB on the laptop is protected. USBs are protected, and I should not get burnt if there's a short or anything. But laptops are more expensive than saving 2 minutes. So I'm going to save myself, spend not even 2 minutes taking some safety precautions. And the safety precaution comes in the form of this thing. That's the FNERC, what a great brand, FNERC, FNB 58, and is a USB tester power supply. It even does kind of a small oscilloscope traces for voltage and amps. And I'm going to use that to power this, so that if this is shorted, this should see it and prevent damage instead of transferring the damage to my PC. So I'm going to need I only have very long cables, which is a bit of a hassle, but I'm going to be plugging in the USB A to C into my PC, and then the A to C will power this thing, which will then be able to power the flight controller. So as you can see, it has some readings for amps and everything. So now if I plug this, we should be able to see what's happening. Let me zoom in so we can get to see. So we're mostly looking at the amps, see if they shoot through the roof and if some lights light up. So we have lights and it's blinking. So it means that we're going to be fine to connect to it on the PC, and the chip is probably fine as well. So that's good. So let me go to screen share and we should be able to connect to it.
If the first one has no damage again.
I mean, it's part of the game. I get given stuff, and if it works fine, then good, it works fine. That's perfect. So yeah, that's working, at least in Betaflight. So we need to do a full assessment of what might be broken. The next thing I'm going to try and see if I can power this up from VBAT. If it doesn't, it means the 5-volt regulator is probably dead. So that's going to be the next thing to fix. And I also check if the 10 volts are present on the 10 volt back. Well, hey Mike, thank you very much for this nice camera setup. I'm still working on it, on giving you a better view of the microscope side when I'm in the scope, so you can get a better idea of what's happening around the scope. But yeah, it's coming together. It's coming together. So that's nice. All right, so let's go, and what I'm going to do is take this, which is my XT30 to JST plug. We're going to make it sure that the pins match what the board wants. And when we have that, we're going to power it up with the bench supply. So this one has a ground on the top edge and then bat. So I'm going to have to dip in this. So for people who haven't been there, removing the cables and putting the cables back in the right position, in another position of those, is a very frequent occurrence when you're working with boards, because it's not standardized. So they all have their own layout, and you need to be super careful not to start injecting 25 volts into something that's not meant to receive 25 volts. That's how you burn stuff. And for example, if you want to use a flight controller with an ESC that's not meant to be part of the stack, there's absolutely no problem doing that, but you will need to possibly redo this this harness. You're going to have to dip in everything and repin everything according to the manual, or sometimes the seal screen on the board. So as you can see here, if I show you, you can see, can you see? Yeah, you can see it has the BAT and GND and all the motors. It's all written on the board. I would say a good 60% of the boards have it written on them. That's really nice. But if it's not written, then you can get it off the manufacturer's website. You just check the documentation for your board, and you'll see what goes where. But it's really important to know that you can actually pair any ESC with any flight controller. Just need to redo the pins. There we go. That one is good. And we should be able to see. So this one is the right motors. There's two large plugs because there's one for motors 5 to 8. So you could run an octocopter from this flight controller. But here we have it plugged. Let's power it up from the power supply. Let me grab this. Grab the XT60. That's something that's super convenient as well if you have a bench power supply. And you probably do, because most chargers can act as a bench power supply. So if you want to test your quads, try your hardware, see if it's damaged, or just do the configuration on your quad, and you don't want to have to keep a LiPo charged or anything like that, I recommend you make yourself a wire that has on one end it's going to have an XT60 that you can plug into your charger, and most chargers you can set them to PSU mode, and you can choose volts and amps, and amp limit and a volt limit, and then you make another end of the cable like this, where you have a bunch of different terminations. So this one I have BT3, BT2, XT30, and XT60, and I can plug it pretty much in anything. That's really convenient to have. So I'll plug this in. On the power supply, I'm on 4S, so 16.8 volts. And I'm going to turn it on now. And you can see if that lights up. Well, it lights up, so that's good. Let me get the meter and see if we have 9 volts as well, or 10 volts. I'm going to bring it to the scope so we see what we're doing. Try to keep the mess to a minimum for now, so we don't start already to be overwhelmed with cables. Let's see, it's not focused for you guys. I'm going to focus it. Give me a sec. So now we're going to be trying to probe. Do we have pads? Yes. Going to look for a 10 volt pad. I'm going to put it to volt mode. GND is here. Do we have 10 volts? So my 10 volt is here. I I'm not getting anything on that. That might be why someone decided. Yeah, that's possibly why someone decided to just. Oh no, no, I'm wrong. That is 10 volts. Just took the meter a second to update. So we have 10 volts.
It's
So
gonna
we're
be
good.
fine.
So yeah. So now what we'll want to do, since everything seems to be fine, all the lights are lit up, gonna want to hook it up to an ESC and spin some motors. Let's turn that off. And once again, it's going to be about making a wire harness to make sure I can connect it to my test rig, which is this thing.
Maybe there's a bent pin in the connector.
Yeah, that's a good thing. The good thing to check. I'll show you. I'm seeing that there isn't, but I'll show you. It's something that's super common when working on when there's some stuff bad happening, like some motors not spinning or stuff like that. So it's always good to check the pins, but as you can see here, it's all good here, all good here, and all good here. So yeah, not an issue on this board. We're gonna be. So now the fun part where I reattach the ESC wires. It's gonna be take a second because I keep swapping the ESC. Obviously, when I test ESCs, I have to put all the motors back in. So we're gonna do it quick.
Are we taking bets here?
Uh,
Because
you
right
can
now it's
take.
looking pretty good.
I mean, if someone wants to bet on not fixed, on broken, they're unlikely to win, but if they win, they're gonna win big.
Yeah. Because right now, even if it doesn't spin a motor, you can probably remap it to
Yep.
another resource, another pad. And
yeah, which would be an interesting thing to show on the stream, actually. So let's hope it doesn't spin a motor.
yeah. Oh, I hope so.
Funnily enough, remapping a pin is not something I've done before. I have good notions of how it works, how you do it, but it's not something I've done. So I'll be interested to fumble around and find how it's done. But I'm pretty sure it's just set resource something, get to see what's on there and set it.
Yeah, the only thing is you have to remember to set all the resources to none.
Yep.
And that's it.
There you go. So that's something that's actually very interesting, very common to know. I received a bunch of broken electronics, and I would say probably a third to a fourth of them are working fine. There are cases where working fine is actually not true. It's just issues that are not really easy to detect on a repair bench. So it could be weird power, weird noise in the gyro that you only see when you start flying or flying aggressively, or it could be some dodgy connections inside the plugs, meaning you get reboots when you crash.
When you hit something, yeah.
Yeah. So yeah, fixed usually means there's 50% chances that it was the build around it, like maybe not enough glue keeping the connector in, so it kind of jiggles and disconnects, or not like a capacitor that went missing and too much noise in the electronics. But it's also half chance that it's a gyro that's going bad, or there is something intermittent, like a broken leg somewhere in a component that kind of acts dodgy when you crash and stuff like that. So it's not an exact science, but yeah. Clyde is saying, nice watch. That watch I've been wearing for like non-stop for 10 years. It's solar, so I don't need to change the battery, and it's radio synced, so I don't need to change the time. So it's been on my wrist non-stop, like, basically non-stop for 10 years. Great stuff.
And it's growing around it.
No, it's fine. It's fine.
All right.
We have Quebec 45S saying another accent. I'm expecting you know how to speak the other kind of French, which is Québécois, which is amazing also. But yeah,
You're
I
gonna
do
offend
have
people saying other kind of French.
one of the other kinds of French. I mean, it's an accent, but it's like it's a dialect. It
Yeah,
has its own
yeah,
expressions, and
it's so different. Yeah.
I 100% didn't mean it to be offensive. But yeah, hey, CIMYK, good evening. Sir FPV as well, good evening. Welcome to the stream. All right, so we got this mounted. Well, let's see if we're lucky and the cable I have on here matches. Well, I already know that it doesn't, but it doesn't match at all. Now, I'm gonna try to see if I have a harness of my 20,000 harnesses that kind of matches. And if I don't, I'll make one. This one actually, this one that came with it has a flight controller side that seems to match ground bat. Yeah. So let's see if this side happens to match. I think it might do actually. It does. Yay. I actually believe for those who don't know, Betaflight has a recommended pinout for flight controllers. They are trying to standardize it, but most manufacturers don't care. And I'm pretty sure that's the recommended one here. And that's why those match, because those happen to respect it. But yeah, I think it's this orientation. I know it's with the motor wires in the middle, but yeah. So we'll see. That should all work. We'll see if we get the motor beeps. That's good. And if we get the motor beeps, it means at least it's communicating fine, and we can test and try to spin the motors. Let's put it in that way. Right. I can remove the USB tester for now. And I can do the power first. So on my power supplies, there's a thing called over current protection, which I have set to 2 amps. So my power supply acts as a smoke stopper, so I don't need to use the smoke stopper. Saves me a few button presses. All right, let's plug that in. And hopefully you'll get the startup sound when I do it. 3, 2, 1.
Yeah.
Okay, those are the good sounds with 2, 2. So it means it's working there. Let's plug in USB and spin them motors. If I can. Right. I have this box. Annoying box. Obviously, if you have any question at any point in the stream, feel free to ask. If you want my attention, for sure, make sure you do an at Krhom, Krhom. So the name will light up in orange when you ask the question, but I'll frequently come and check the chat to make sure I don't miss anything. Let's spin those motors. So you should, let me zoom out the side view so you can see if it works. But I'm kind of, oh, so something interesting. This board has a mid setup called bidirectional D-shot. I'm going to do that now. That will let us know if the communication is good on all 4 motors. And that's something, actually, let me turn it off. I'll show you. For those who don't know, when you have bidirectional D-shot enabled, some of the ESC sends back some telemetry data to the flight controller. And if the flight controller doesn't receive some of them, it will tell you in red with the error amount. And because I just turned off the power supply, the ESC is off. and it's showing 100% error. That's a good way to test if the motors are communicating well. So I'm going to turn it back on now, and we should see that go to white and 0%. There we go. So now we know all 4 of them are communicating, and let's try spinning the motors. Got triggered the overcurrent protection, obviously, because that acts as a smoke stopper. Same thing as a smoke stopper. When you spin the motors, it draws too much current, so it stops it. So I'm turned off the overcurrent protection. I will now spin the motors. And you can see from the LEDs that it's all spinning okay. So that's pretty good. We should probably just hook up the receiver and try hovering it to make sure it's all working before I place it in the bin of the stuff that works. For those who are new to the stream, I try to always at least test flight indoors, so just a simple hover of all the electronics I fix, so I'm sure it's at least airworthy. We have a question from Sir FPV. Did I twist the power and ground wires from the harness, and is that beneficial, and if so, why? It's something that some of the wires do. The harnesses you get, they have that. It's absolutely not necessary. There's no real relevant noise that comes through those wires. There is an argument that most of the noise in the system comes from the motor commutation, so from the FETs turning on and off on the motors, and the back EMF from the motors, and that is fed back on the positive line. So technically, there is noise on that thing. Does crossing it with the black wire stop that noise? Probably not, because twisting tends to block electromagnetic noise that comes off the components themselves, not through the electrical path. So maybe a bit. I've never done it. Some harnesses have it done that way.
Yeah, diatone ones come like that.
Yeah, I can't say I ever tested with and without. It definitely, you can get a very good quad with low noise and good performance that you can push the tune on without this. It's a bit of a, yeah, why not? It's there. I'm not going to undo it, but yeah, I don't think it does a lot. Something that would be interesting to know. Oh, Liviu is here and can probably tell you a bit more. Yeah, so that's what I was hinting at, Liviu, saying it protects them from EMIs, which is the electromagnetic interference that gets emitted around the components. But I would bet that the amount of interference emitted that can be picked up by the wire is just dwarfed by the electrical noise in the circuit itself. But yeah. Hey, Mike Shaky FPV. Why don't people shield the motor wires? Wouldn't the PWM create a lot of broadband EMI? That's something that maybe Liviu can tell you more about. I'm not an electrical engineer, and all the knowledge I have around that kind of stuff, it's kind of stuff I've kind of heard and learned by doing and by listening and stuff like that. I don't expect there's enough that it would create any significant interference in our flight controller, since we actually can fly drones quite well. So by experience, it's not needed. There is something, though, that's worth mentioning. You'll see a bunch of people, so oftentimes you'll see people run their wires behind the standoff, over the ESC and into the pads. And it's super cool looking. Like you have your nicely coiled wires around the thing. And yeah, it looks great. It's a bad idea because that's kind of the opposite of shielding the motor wires. You will be making sure all the EMI produced by the FETs is being dumped into the wires, and all the radiation emitted by the wires themselves is being dumped into the board and into the flight controller above. And I've seen cases where you have bad gyros that become good once you remove those wires going over. I've seen it once on one of my, but the first time I've did it, and the only time I've done it before I knew better, I had that case, and I rewired motor wires, the problem went away. Other reasons you wouldn't want to do that is because it makes maintenance horrible. If you break an arm or need to swap a motor, you can't really access it, so you're going to have to solder it on the front anyway.
And it weighs more.
Yeah, it's extra weight. It's less cooling, more space. So the space between the boards is extremely important, mostly because boards move and crash into each other when you crash, and they will hit each other and break each other and short each other. And most of the fires you see in crashes come from one board slamming into the other and causing a short. So any room you steal from that spacing is a bad thing. You want as much space as possible between the boards. It also means that you get less cooling. Well, it's overall a very bad idea, so don't do it. Hey, Balu. Good evening. Welcome to the stream. Leave you saying that regular motor wires are too thin, but they do generate a bunch of EMI. And too thin means they heat up quite a lot. Oh yeah, it would be good to show this. To see, I can show you the wire light up. I can show you the wires light up actually. Is that something that would be sharing? Because I do have a camera for that. So let's see. I want to see if the race wires also light up. So I'm gonna see if I can set that up for you guys. I'll see if I can put my phone, attach my phone somewhere where I can.
And check the RPMs when you do that. I think there was one with like 3,000 or 4,000 RPMs less.
Yes, but that's
the ESC, but
that's a known bad ESC. That's an ESC that desyncs. So
okay, that makes sense then.
The flight controller shouldn't affect any of that.
Yeah.
Let me see if I can try to not short. Wait, I'll put some tape around this thing so I don't accidentally short it somewhere. Poopy asked why such long motor from motor wire to ESC. That is because I test a bunch of things on this test rig, and when I test small AIOs, I need more wire. So that's not something you should do. That's something I do for my bench machine. That is a very good question. But yeah, thankfully you guys keep the wires with a bit of slack, but short enough. Hey, Joseph. Welcome to the stream. I'm hoping you will be streaming soon, joining me on the madness of repairing stuff. Also, I just blocked the USB, which is very dumb. So that was not very clever. Let's see if I can keep the USB available. There we go. All right. Now I don't run the risk of shorting anything. And we should be able to see some thermals. So I'll try to, let me remove the macro lens. So we have, let me put it the other way, you guys should see it quite well. All right, so let's power it on. Okay, so you probably don't see the temperature, but let me start spinning the motors quickly. Up. Oh, there's some stuff blocked. Or something, yeah. Oh, you can't. I think we might be limited by the power supply. The power supply is clicking from other amp draws, so we're not seeing the wires heat up too much. We see them getting up to room temp, a bit over room temp, 30 degrees there, but we're still quite cold. So yeah, I don't think unfortunately, I don't have Livyu's big PSU that can trigger big loads on the motors. But, oh well, we tried.
Just
I
put a
got to.
lipo.
I mean, I can. That's a good point. I do have one around.
The point, yeah, I missed a few seconds. The point is to see if the wires get hot.
To see that the wires get hot for people to see how much
Yes.
it happens. Up. There we go. It's a bit annoying because I don't have.
See a fire.
I don't have a mouse to trigger the. Well.
Oops.
That's the desyncing ASC that I was. Oh yeah, I think that's. We can see it. We can see the race wires heat up. We can see the wires heat up. They're about 35 degrees now. So yeah, we can see it heat up. I feel like it's a bit dodgy with the quad moving around, so I'm going to stop there. But it's interesting. Actually, let me check the thing you said before. I'll run them at a low RPM and see that if that.
It was the third one, I think. Yeah.
Yeah. So the third one is the desyncing one, and we saw it desync here. You heard the beeps reboot, and that's the one that desyncs. It's good enough for the test bench, but it's not good enough to fly. That's why it's on my test bench. But yeah, it means at some point I'm going to have to investigate, see if one phase is not working, something like that. That could explain why it's desyncing.
If we can figure this out, I have a few ESCs that would need it.
I have a feeling that I won't be able to diagnose it without a scope, an oscilloscope. But yeah, I'm not sure if it would be, if it's the.
No, but the next clue, like we said last time, was you had a good idea to try to install AM32 on it.
Yes.
And see if the issue is still there or not.
Yeah, this won't work here because it's BlueJ, but yeah, that would be an idea. Smooth noticed that this quad had the Zelda sound, which I've kind of stopped doing sounds on my quads just because I know why. That's because I run ESC that you can't set the sounds on. But yeah, it's always I usually if someone gives me a quad to tinker on, I will put Never Gonna Give You Up on it, so they get a good surprise, a nice surprise when they boot it up. But
that's evil, man.
But yeah. All right, so we're gonna. To be honest, I think I'm gonna try working on the next part. I'll do the flight test offline just because if I might do it at the end of the session, but it takes a bit of time to get it all configured and everything. So to save some time for the stream and you can fix more stuff, I'll keep that on the side. And I'll do the test offline. So we consider this fixed, and if it's not, I'll bring it back on another live stream. Let's keep going with that box. Let's see what else we can do. Can we? Maybe we'll find another FC that's also not broken. So what do we have here? Gep RC. Oh, this one looks nice with the what's it called? The Bluetooth module. That is a T-Motor Velox SE. It looks like it's been above a fire. All right, let's try this one. It looks fancy and shit. So, and there might be there's two of them. So Donéo. Let's see if we can quickly see what those have. Hey Baloo, let me know in a DM what the news is. All right. So we're gonna do the same thing. I'm gonna pull back the FNERC again. and double check what they're doing on USB. So first one is, where are the LEDs? They're on the other side. Okay, it seems to be working. Let's have a look here. Just tidying up a few things. Let's see if we can get... Well, that's also a good sign. Right, that's moving. All good. And let's try the second one. And those repair streams, they go so quick. Everything is very easy to repair when it's not broken. Well, this one does it like that as well. Right. Same thing, seems to be working fine. So if I show
How
you
many working FCs in a row?
Yeah, I mean, that makes for less interesting streams, but I try to show you all the steps I use to ensure everything's working as intended. We have a question from Smooth. You're building KU Mini and you're struggling with layout, antennas, power wires, and anywhere I can see your KM build. It's on my Discord. There is a section called builds, and it's pinned in the builds. It's called KU Mini 04 12mm build log. And it has all the photos, all the steps. I don't think I would recommend building it on 12mm standoffs unless you have the same flight controller as I have, which is not produced anymore. It's actually this one. So I do have one spare somewhere. And the reason it's particularly good, yeah, that's it here. It wasn't in the KU Mini, but so why this one I'm sad doesn't exist anymore. It's because it doesn't have a USB plug sticking out the back. So it has the plugs here, but you can remove them. You should remove them if you're doing a KU Mini. But it has the USB plug here. And so it's super low profile when it doesn't have the plugs. And that's what allows you to build 12mm. You can build it with some of them that have the USB sticking at the bottom, but the USB will stick out the bottom of the quad and probably catch on something and break. So not something I would like. Some people have had good success putting a TPU cap on the USB that kind of secures it in the hole in the frame. But I would just build it with 14mm standoffs. It doesn't change anything besides bragging rights. So just build it on 14 and you'll have plenty of room. Donéo, who's the author of those flight controllers, not the author, but the provider, is telling me why that I will see why he hates those flight controllers. I guess I'll see, but at least for now. This one needs a bit of a cleaning, actually, so let's do that quickly. But then we'll test the same way. We'll test by giving them VBAT and see if they light up. But first, a bit of a clean with some IPA. IPA being isopropyl alcohol or rubbing alcohol. And it doesn't dissolve everything, but it's pretty good at not conducting electricity. So cleaning that is probably better with water in terms of dissolving the actual stuff that's on it. But water does conduct electricity, then can cause shorts. So I would need to make sure it's properly dried before plugging it in. And I don't want to have to wait. So I'll clean it up with IPA, at least to some extent. Yeah, I can smell. I just smelled the board, and I can smell a burnt electronic smell. So I'm pretty sure this was on top of an ESC that burnt. That's why it's all dirty. I can show you under the scope actually, but It doesn't look that bad, but you can see here it's kind of burnt around here. We'll see. We'll see if that means there's something to fix there. We'll see. Let's go back to overhead and let's sort out our connector. So what are the chances it uses the same plug as the previous one? Okay, so I'll look under the microscope actually, because it's hard to see, hard to read. So yeah, the motors are at the end, and then we have BAT and G as the first ones. So it's definitely not the same, but it's BAT then G instead of G then BAT. So I'm going to swap the two wires. If you absolutely hate repinning wire harnesses like that, don't do FPV electronics repairs. It's just part of life, part of what we do. We keep pulling those tabs and putting the wires back in somewhere else, over and over and over again. Oh, Donéo saying he stole the flight controllers because he burnt an ESC on the first flight and then never touched them again. So it's likely the flight controllers were blamed for something they didn't do. Let's hope that's the case. They can go back into service. I'll show you something fun with those ESC if they work as well. Something you might not know. So now we should have the right thing plugged in the right place. And let's go for VBAT, 3 to 1. Yeah, looks like it's working. Let's go under the scope and check for voltage on the 10 volt back. Let's find 10 volts or 9 volts. Here, we'll have one here. We should have one here. And I'm reading 10 volts. All good. Let's try the other one. Don't you enjoy seeing my disgusting fingers in a high res? LEDs are somewhere. Let's power it up. Yep, looks like it's... Oh, the middle one isn't lit up. Interesting. Does it mean the 10 volt back is not working? I think I'm getting 10 volts. I don't know what this LED is. It says nothing. So I don't know.
Is it 5 volt?
There's no thing to indicate that it would be. So I don't know. I can poke, actually. I can try to see what voltage it has on its... there's nothing here. That's ground side, so that will be... Let me do the opposite. That's 3.3. Yeah, that's 3.3 volt. So the LED, did the other one light up actually? Let's have a look. Could be that the 3.3 LED is dead, but the 3.3 rail is working because that's the thing that powers the MCU. And since we have the blinking light, it means the MCU is powered. So
Can you switch to full screen?
Yes, absolutely. Thank you.
Thank you.
Yeah, so this one, oh, it lights up for a second, then kind of dies out. Oh, this one blinks at a different frequency too. That's weird. Let's plug them through USB while they're powered up. What do we have? Oh, so then, interesting. This one's having issues reading voltage. So like
Oof,
the
and it was blinking. Yeah.
the ADC seems to be broken. Oh, and I moved it and then it's working. It's kind of climbing. So yeah, there's something wrong with this thing, at least the ADC. The ADC is the analog to digital converter that's used to read the VBAT, the voltage to display it on the OSD, so you know where if your battery is dying. So yeah, that's an interesting problem. The gyro itself seems fine. There is some drift, but nothing unexpected.
That's the first one that you took a look at?
That's the burnt one. Let's have a
Yeah,
look at the
I
other one.
think I saw a burnt pin on the MCU the first time
Yeah,
you looked at it. But I'm not.
we can have a look. We'll try to have a look. Do we still get the drift? Oh, interesting. I think it might have overheated. And I feel that the board is quite hot. There is something wrong with this board. And I think, yeah, there might be something pulling a bunch of amps on the 3.3 volts. It doesn't seem to be the gyro because gyro
Thermal
is...
cam time.
So let's have a look at the other one while plugged in and we'll see which one we start with. But there is some investigation that needs doing here. That's good, good. So that seems to be working. Do we see the same kind of drift? We don't see the same kind of drift on the gyro. I don't know if you noticed before, but the yaw was ticking. Like
I
every
didn't
second it
see.
was ticking to the right. I'll show you again when it's cooled down. Let's give it power. The ADC is working. You can see at the top the voltage is read correctly. So I think this one is blinking healthily. So I think that's probably fine. Let's have a quick look with the thermal cam, see if we can see something wrong. We're gonna have to look at the other one with the thermal cam anyway.
Yeah.
Let me zoom out a bit so you can see the cam. I've put back there. Right, so the MCU is hot. The thing that powers the MCU is hot, but not too hot. It's like 40 degrees. So nothing worrying here. And that's the LDO, that's a regulator that converts 5 volts to 3.3 and powers the MCU. So it's normal that it's hot. And here we have the back that that converts VBAT to 5 volts. It's 32 degrees. That's perfectly fine. Everything within normal operating temperatures. If I show you the screen shares, everything seems to be working again still. So I'll put this one on the fixed quote-unquote bin, and I'll put it on the quad and fly it later. So this one looks fine. And let's focus on the other one. All right, so let's see if we can see something with first the I'll put the top-down camera. So can I connect to it actually? It seems to be not connecting. Let's see if we can see something getting hot. Okay, that's getting quite hot. 55. That's a diode that feeds the back probably. Nothing obvious, to be honest. That's getting 61 degrees, and that's 100 degrees on the MCU.
That's super, yeah.
So
MCU
100
is
degrees
short.
on the MCU means the MCU is shorted somewhere. Funnily enough, it's still connected. I just saw it connect on the side, and it still works and gets to the gyro. So let's see if we can fix it maybe before we try swapping it. Let's start doing a thorough inspection under the microscope. That's probably the first thing we want to do. Let me grab some fine tweezers. We can poke at things. At one point, if anyone wants a tour of what a flight controller is and how it works, let me know. I can do that whenever requested. But yeah. Donéo is confirming that it was getting really hot when plugged onto USB, and it was indeed. So let me zoom in and do a clean focus on the pads. There's some stuff here. Nothing that looks... And definitely there was some fire. It could be as stupid as some carbon deposits shorting something, but there definitely was some fire. That's the barometer. Can we see anything? Ah, that's probably not helping.
Oof. Oh yeah, that's going straight to the MCU.
Yeah, well, we'll remove those, but I don't think that's going to be the issue, but definitely clean this up. That's a completely oversized pad. I love doing that kind of stuff under the scope just because you get such a clean view of what's happening. Let me grab. I'll do that. I'll clean them up proper after I remove the bulk of the stuff. I'll grab a bit of wick. Actually, let me do it properly, which consists of putting this in a holder. Don't worry, the focus is going to come. There we go. Focus, focus, focus. Yeah, and we'll do it with a bit of wick. There we go. There we go. Let's clean up with... I'm really loving the sponges. So last week I started using those tiny sponges to clean stuff up. I'll show you how it works. The workflow is use that dispenser, which is a few bucks on AliExpress. I use some of those pliers that stay closed. Get some piece of foam there, and then I press it and kind of soak some IPA on the foam, and then it acts at both a dispenser for IPA, and it soaks the flux on the back of the sponge, as you can see. So it's really nice. I'm really enjoying using those. Let's see if we can get it to clean the pins as well. I'm half of a mind of, if I decide I want to swap this chip, try to reflow it first, just in case there's something corroded or something like that. But there we go. What we can do as well is take some measurements on both boards. Since we have a board that works, we can do some comparison measurements of different parts. What would be interesting to find is the circuitry that's plugged into the ADC. So the way an ADC works is you want the pin of there's a pin on this chip. So that's the processor, the MCU, microcontroller unit. And somewhere, one of those pins is configured to read an analog signal. And that analog signal is going to be a voltage, and it's going to be translated to a number that the processor can display on the OSD to show you battery voltage. However, this MCU operates at 3.3 volts. So if you were to give it VBAT on one pin, it would blow, it would explode. because it wants up to 3.3 volts. So the way you feed it a signal that's readable to it is by using a voltage divider, which is just two resistors. So you have two resistors in series. Let me take something as an example. So do we have two resistors in series somewhere? Hard to see. So let's imagine this resistor is in series to this one. So that would be the pin. No, VBAT on one side. Then in the middle, you connect the pin. And then that's the same trace. And then that goes to ground. And what it means is depending on the ratio of those resistance, of the resistant values of those two resistances, it will have a voltage in the middle that's proportional to VBAT, but a smaller number. So you choose your resistances, your resistor values, you choose them in order to bring the maximum operating voltage, maybe 25 volts, down to 3.3. So when the battery is at 0, it would be 0, and when the battery is at 25, it would be 3.3. And that voltage divider is somewhere on this board. And we can try to kind of have a look at the traces, see there's something obvious that it could be. I don't know what pin it would be. But for example, it can't be those two, because those, they go from this pin to this resistor. It could be, that goes to a via. It means it goes to the other side of the board. So I don't know where it goes, but we could investigate. But what I can do is try to find the pin that has some amount of resistance to VBAT. That should tell me a bit of what pin it could be. I don't know exactly if I'm going to be able to get any valuable information from seeing that, but I can kind of check the values of the resistors and see where it goes. So soon I'll be able to show you the resistance, the values I read on the meter on stream. It's coming soon when I have time to hook it up. So I'm gonna try to find a VBAT pad, but there's one here. And I'm gonna try to see, so here 45 overload. Yeah, there's a bunch of pins that have some amount of continuity, so I don't think I'm gonna be, this one had 20 kilo ohm, over 20 mega ohm. Yeah, I don't think I'm gonna be able to get some information just by not knowing how it's been designed and what resistor values I'm looking for. But to show the example, actually, now, okay, so what next? What I can do is see if I can find any obvious shorts in some capacitors that would be useful. So I'm gonna go in continuity mode. I'm gonna try a bunch of, so that's the mode that beeps. And capacitors usually should never be shorted. So I'm gonna start testing a bunch of capacitors, see if I can hear some beeps. I'm not exactly sure. No, right? Interesting. Did I get lucky? Yeah, so that's 10 ohms. It could be normal that it's 10 ohms, but what we're going to do is take the other board and check if it's normal that it's 10 ohms. I'll try to hold it in the same vise at the same time. They won't. They don't want to stay in at the same time. I do have another vise that could help us. But let's see if this is supposed to be 10 ohms too. Doesn't seem to be.
Nope. It's not even the same color.
Yeah, it's 400
doesn't
ohms.
mean anything, but
400 ohms I get on the other one. So the when I measure in circuit like this, I'm not measuring the resistance value of the capacitor. A capacitor is not, when I measure 400 ohms on the other one, it's not the capacitor I'm measuring, it's some other resistance somewhere in the circuit. But this seems like it's blown in some way. So What part of the circuit is this? I'm not sure. I'm not really sure, to be honest. It seems to be filtering. So that's the ground plane. That's big ground, probably. Yeah. And that's could be filtering for the 5 volt. And if it's shorted, that would for the 3.3. That's the 3.3. That's the big 3.3 regulator. It's actually written on it, actually. And that's probably the other 3.3 for the gyro, because on the ICM gyro, you want one for each. So yeah, I'll see if I remove this, if the short clears. And if not, we'll see if we can find what does.
Wasn't there a Beck that was getting real hot on the other side with the thermal cam?
Yeah, it was this one, the 5.5, the 3.3 regulator. But that's normal. If something's shorted, it's gonna get hot.
Yeah. Oh no, I thought it was on the other side next to the OSD chip or something.
No, that was on the other one. I didn't. I don't remember seeing anything worrying on this one.
Okay.
I'll start by removing this cap and see if
Yeah,
by
this one
chance.
is definitely a goner.
No, not definitely. It could be the short could be somewhere else. We could see what else is shorted actually. Do we have? So this is not on the same rail. It looked like it's on the joining the same pads, but it's not now. So, oh, it is. Okay, so this one's shorted too. And this one, this one might not be, because if I zoom in, you can kind of see the traces to some extent. Let me focus it right. Can you guys see correctly? Not perfectly. You can kind of see the traces, right? You see there's a via here, and this is a pool. It's probably ground. Let me confirm that this is ground. It's not. See, yes, it is. Yeah, so that's a ground pool. So that's between ground and probably 3.3, but maybe, yeah. Oh no, it's shorted, so any ground will be, obviously. So, and this looks like it's connected to a different path. So this one might not be on the same. So it could be this, it could be something else entirely. I tend to think that it's probably not the capacitor, usually, when it's not blown visibly, but it can be. Yeah, this is interesting, but definitely there's an issue here. It could just be the STM. It's probably the STM because that's the thing that was getting super hot. So yeah, I'm kind of thinking it's probably the STM shorted somewhere. I don't think we're gonna get away with not removing it. So I think we're gonna remove this. That's most likely to be the issue. We're gonna remove it, see if the short's gone. If the short's gone, then it's definitely. It's a shame because it's broken, but it's also not super broken. So it's a shame to kind of toss it for that. So there's a world where we just can get rid of the part that's shorted and still work with the rest of the MCU. But it's hard to tell when you don't know, when you don't have the files to know what's connected to what you're losing when you're not using that. So yeah. Liv, you saying that we want to see what's hot on the 3.3. I checked that before, and the only two things that are getting really hot is the LGO and the MCU. So from experience, it's 90% that is the STU, and you'll agree with that. So yeah, I'll remove the MCU, and yeah, that's a shame because it kind of works, and I hate seeing stuff that kind of works being thrown away. But there's no way I can fix the MCU itself. That's not something that's possible to fix. So let's remove it. I'll go for a good 400 degrees hot air. Let me grab my tweezers and let's go. Let's go full blast actually. 99% airflow. and go for a quick pull. This one is nice because it's not too close to other components, so I shouldn't have any issues. Oh, wait. Wait. I do have a new toy. I need to try the new toy. Where's my new toy? Here's my new toy. Maybe it's going to be terrible because it was only a few euros. But I have this thing. This is a vacuum suction pen that you can use
Yes.
to press a button to and release to generate a vacuum and pull the chips. Let's see if that works. Probably not. It's probably going to be awful, but we'll see. Let's go back to the microscope.
What I asked was if you placed the 3.3 volt from the power supply on the 3.3 volt line, not just LiPo power.
Ah, I didn't try that. I could have, but right now I'm going to take the risk that and say it's the MCU, like you say, is very likely. But that's a good point. I need to remember which pin of the. Do we have a? I don't know. Do we have a 3.3 volts pad? That's not. Because if we don't have a 3.3 volt pad, I need to go and put it on the put a wire on the LDO, I expect.
Yeah, this is the simplest method. You find the 3.3 volt line, you feed in external 3.3 volt with 3-4 amps or something like that. You spray some alcohol on the board, and voila, you know which part is
Yep.
bad. You know?
I've done it before with a 5 volt. I never thought to do it on the. Oh, that works fine. That works great.
Perfect.
Yeah, that was cool. Chipped has been pulled and still stuck to my thing as well. So yeah, a few euros well spent. Right, let's see if it's gone. If the short is gone. There we go. We have the beepy beeps. Ground. Yeah,
I replaced one of those yesterday.
Yeah, that's. It's been a few streams I haven't done it, but it seems to be a good 50% of the fixes is replacing the STM. All right. So yeah, that clears the short. So we're gonna slap on a new STM, and it's probably gonna be it. Let's clean it up.
Almost all the inputs from the MCU are 3.3 or 5 volts tolerant. So if anybody shorts it even for a second some LiPo level
Yep.
voltage, the MCU dies instantly.
Yep. I'm going to try today, I'm going to try to do it the cleanest way I know, which is add some leaded, wick everything, put back some clean leaded. It's not needed. I could just slap on the new thing and melt it with a leaded solder, but I want to have fun doing it the nice and clean way. I'm going to put on a tip that's not going to go red hot, hopefully. And I'll start by adding some leaded. That's kind of the things you see if you see repair videos on Instagram or TikTok or Shorts. You see them do that kind of stuff all the time, where you kind of add some leaded, clean up, make it nice and clean, adds tons of flux, and it looks cool. So I want to look cool too.
Yeah, that's mostly because leaded melts at a way lower temperature. You
Yeah.
have solder that melts around 180 to 210, and leaded usually unleaded, sorry, it's around 250 or something.
Yeah. It's definitely like I've soldered them back on with the unleaded on the board and it works fine. But, you know, why not enjoy doing a clean job, a good job, an unnecessarily good job? We know it's going to crush and burn anyway now.
Right next to the fire down there. That's already on the board.
Yep. Okay, so I'm cut a bit of wick. For people who are not used to wick, it's good to always cut your wick so you don't have, if you don't cut it off the wheel, it will try to soak up all the heat into the wheel of wick. So always cut small bits of wick off and work off small cut bits, or it's gonna work well. It's not gonna work as well. And obviously plenty of flux. There we go, clean pads. Now we're gonna clean up the flux with my small sponges. Where are you, sponge? SpongeBob, where are you? There we go. Found it. My the wire from my soldering iron keeps triggering my fancy automatic tip cleaner. There we go, nice and clean. Now we're gonna dirty it again immediately by putting in some more flux. There we go. Let's get a clean tip for my iron. Oh. It's probably not the best tip for this, but it will work fine.
What size is that? Is that the 245 or 210?
Yeah, it's a big 245.
Yeah, 245.
This one doesn't want to take solder at the end. It's probably a ground. Let me grab a more appropriate tip, actually. Let's go for this guy. Good. The bent conical isn't great for this. I'll go for a chisel. No, my tip is bugged out. I'm sick of the shitty AliExpress tips. There we go. Sometimes the cheap ones, they don't get detected well by the iron and doesn't know how much power to put into it, but hopefully it doesn't start glowing red. The reason I'm saying this, if you missed last week's stream, we got an iron tip that started glowing red in my hand, and I only noticed after a while, so it was funny. I was pointing at stuff with the iron glowing red or even white hot, and yeah, a bit of a surprise. They're not supposed to do that, so that was a bit of a surprise. But yeah, with the correct iron tip, it works well. I can now clean it up again, put some more flux, fresh flux. The reason we keep cleaning and putting some more flux is because the flux gets used up when we heat it up. So we need to keep cleaning it and reapplying some fresh flux. That is the way of the flux. You have to refresh it all the time. Yeah, so we have some nicely tinned pads. Now we're gonna have, so question is, I didn't even check what kind of MCU this was. I'm expecting it's an F7. Let's have a look. F7. So this goes in the, I have a graveyard of F7 chips, or old chips. I'm gonna open the small box F7s. Try to not break it. Gonna have to add some solder, some flux, I mean. So the orientation is correct here because we have the, that's the crystal, so the oscillator here, and the pin 1 goes here, which opposite the oscillator. Let me put that away and give the board some flux. And then we'll reflow it into place. So the alignment part is always a bit fiddly. There's many ways to do this. I tend to try to align it well first and then kind of reflow it on the spot, which I think I just... Did I just do it? No, it's not. And was it? Maybe it was. It's...
And the vacuum thing help you?
I don't think so. I think I prefer doing it that way. I'm getting decent at it. So...
Oh man, whenever I touch it with tweezers, the thing flies off.
Yeah, it's... I managed to get a decently steady hand on some days. I think I'm pretty much on it. Yep.
That looks good, yeah.
Yeah, let's go for 50% airflow, same heat. I don't want to blow the STM away, so I'm gonna go with a lower airflow, and I'm gonna not touch it until I see all the pads melt. So we are looking for meltage of the pads. It should come sooner than it did when removing it, because it's now leaded solder, or solder, as you say in the States. It started to melt on the top. You can see it. Now let's try tapping it a bit. Just making sure all the pins are making good contact. Yeah, I think we're good. I'll come off the heat and then I'll test all pins one by one to make sure I got them good. I'm still not super confident. I haven't done a perfect one very often. So I think I've done once where I didn't need to retouch any pin. So I'll see where I got this time. Okay. So I'm gently pulling on each leg to see if they move, and the whole holder is moving. Okay. That's looking good on this side. Okay. Let's do counterclockwise rotations, so I don't do the same side twice. And it's looking good. Maybe the cleaning up
going to be
and
your first
perfect? That would be my second. I've done once, but it could... I think the cleaning it up and using fresh leaded is probably a good idea, actually. Doesn't take very long. I like that those tweezers, they can go between the legs, so it's nice to test. Yeah, that's starting to look pretty good. Some of the way I learned doing electronics repairs by watching people on YouTube, and one of them is Northridge Fix, which is one of the big repair channels on YouTube. And when I saw him test pins with his tweezers like I do, I thought, yeah, maybe I'm not that bad. If he does it, it means it does happen that you mess it up. So it takes a second to check, and then you have peace of mind that it's working fine. So let's clean it all up. Can probably confirm we no longer have the short. I mean, there's no reason it would have come back on a fresh MCU, but that would be here. I'm not in beep mode, am I? I am in beep mode. No beeps. Yeah, we have a 400 ohm resistance, which is the same as what we had on the other board. So yeah, that's looking pretty good. Now we're gonna test it. Hello, Mathieu there. Welcome to the stream where we try to fix stuff, and we actually have had something to fix today. That's good. All right, so now we'll plug it in. I don't have to guess at what the target's going to be to flash on this because I have another one, so I can just check. So I'll put this one in, and I can see on the top left, it's a T-Motor Velox F7 SE. So now, for people who don't know, because I just put a new MCU, the MCU is empty. I need to flash it, but I won't be able to connect it to flash to it, so I need to put it in bootloader mode using the button. So the way you do this, you find the button on the board, the boot button. You hold it while you press the, when you plug in the USB. That's going to put it in STU mode. Then you go to your configurator. And here it has already detected it, but if it doesn't, you go to can't find my DFU device. Then you go to update firmware, type the name of the board. T-Motor Velox F7 SE. That's the one. Let's go for digital. Where's the remove all that shit that I don't use? The reason I remove it is on some F7 boards, if you run 8K PID loop and the short 600, sometimes you lose the OSD because the processor is needed. And when it runs out of resources, the first thing that goes is the OSD. So if you see a flickering OSD, try reflashing and removing a bunch of options here, or run 4K PID loop. You probably won't notice a difference anyway. There you go, let's flash. As always, any questions you have on related to building drones in general or repairing electronics, feel free to ask. I'm happy to tell you all I know, how to diagnose stuff, how to test how stuff works. So it's blinking. I can see it blinking. So now it's working fine. Looks like it's working fine. Let's go back to the screen share and see if we can connect to it. Can't find my USB device. There we go. Stuff's not calibrated. The gyro moves. Let's do a quick temp check. See if the over temperature is gone. Let's go back to the overhead for the thermal cam. And we're getting normal 35-40 degrees temperatures on everything. Now we're going to plug in a LiPo and see if we get the correct voltage on the ADC. So that's still the same plug, thankfully. Plug it in here. And then let's have a look. So we're looking at the top of the screen where it says 60. Oh, I had the PSU on already, so it's already confirmed. You can see 16 volts at the top of the screen. If I turn off the PSU, it's going to go down. So the ADC circuitry works. It was a pin that was shorted somewhere on the MCU, unfortunately, for the MCU. So yeah, that's an easy repair for the MCU. That's one of the most common repairs I do. So I'll mark this as fixed and I'll put it in the bin to be tested on a quad to make sure it all works. But that's those kind of fixes, I'm quite confident that will hold the line, because usually when stuff breaks, like the first weakest link breaks, in this case was the MCU, and then it usually, the rest usually works. It's not a given, but sometimes it can be cascading failures. Right, let's bring back the box. We're an hour and a half in and we've quote-unquote fixed 3 boards. Well, that's,
yeah, that sucks that
one.
it's the weakest link is the most expensive component on the board.
Yeah, it is on, I'm guess if you were to buy them in large quantities, it would probably be cheaper. At the moment, I'm paying about €5, a bit over €5 per STM F7, and a bit over 4.3, can't remember for the 405. So gives you a bit of an idea. It's definitely cheaper than the whole board. Those boards aren't cheaper. Oh, that was something I wanted to show you actually on those boards. There's a question from Smooth. And saying another question, if it's okay. It's absolutely okay to ask any question you want. That's why I do the stream. So yeah, you're absolutely welcome to ask. If you have a Betaflight F423 SAIO and all 4 ESCs stopped working, motors play the startup sound very quickly and don't spin. So when you say motors play the startup sound very quickly, that's something you would need to post a video of it on my Discord, and we can kind of start picking up from there. On an AIO, if the that's a bit of a weird one, because the communication between ESCs and FC is not something we can really change. It's hardwired in the board. So if there's something wrong in the communication, it's not going to be something we can easily fix. So it's very faint. So first step for me would be to remove everything, clean everything with, like, use Wick to clean all the pads, and then do a sanity check in Betaflight. So the thing that I showed earlier, where you see the bidirectional D-shot error, so what I would do is plug USB, enable bidirectional D-shot, make sure the ESCs are flash for it. So you have to have BlueJ on them. I think they ship with BlueJ anyway. So you look at the error being 100% and red, and then you plug in the LiPo, and you see if the numbers go white. If they go white and to 0%, it means at least the FC and ESC is communicating. Then I will take a known working motor on one of the motor outputs, and I would wire it up and see if I can get that to spin. What you're saying suggests to me that you might have been testing on a dead LiPo. You didn't realize that's something. I'm not really kidding. I'm not kidding. Something that has happened to me. It's like I'm debugging stuff, and at some point it just starts getting weak signals and like start playing the music on a loop and stuff like that, and I just start debugging. And it take me 15 minutes to realize my LiPo went to. It was a 1S LiPo. It went to like 2 volts or something like that, and just, yeah. So make sure you have a charged LiPo when you test this. And do those checks and ping me on my Discord, and we can have a look further. I absolutely, I love helping people fix electronics, so you're welcome to poke me and send me data, and we can start working on it together. SerafPV asks, is it possible to upgrade the STM on an AIO? It is not, because the pinout of those chips and the hardware and the software on them is different from one chip to another. So even if you were to work on a target, meaning the target is the configuration telling Betaflight what pin goes to what UART, what pin goes to what feature. Even if you were to reprogram this for the right MCU, so from F4 to F7, for example, well, when you solder that MCU on the board, maybe one pin that used to be a UART is now the VBAT or something, and not all those pins can be swapped around on an STM. There are some pins that can, some pins that have to be the one that receives the power, the one that receives the crystal signal and stuff like that. So mostly it's not possible. So I think next we're probably gonna want to be looking at an ESC, maybe, if we can close the day with an ESC. So let me grab the box where did I put the box? There. Let's go. What do we have in here? Do we have one that we have two of, so we can ensure we have a donor? What spacing is this? I'm curious. What the hell? What spacing this is? Because that looks like 2020.
Is that the TBS one?
Oh, it is 3030. It's just a
Oh,
long
no.
3030 boy.
Yeah.
That must be a pain to fit in some frames. Okay, so maybe not this guy first. Man, he sent me a lot of flight controllers. That's good because that was I have a bunch more ESCs than flight controllers. They're all different, I think. Yeah, they're all different. This one is conformal coated, so it looks fancy AF. So we're gonna look at this, maybe. Yeah, let's do this one. The fact that it's conformal coated is gonna annoy me if I need to poke at stuff with a multimeter, but will do. Will do. So, for those who haven't seen my 7-step or how many steps of assessing what's wrong with an ESC, well, let me start by cleaning up the pads actually, because there's some shorting going on here. So let's go under the scope. Let's go and focus on stuff. Yeah, it's nicely focused. Let's clean that up. Put on a bigger pan, a bigger tip. I said pan. Pan is not the right English word. We say pan in French for a tip, but that was not the correct word here. Let's see if I can just kind of grab. Yeah, I can just grab it with the arrow. So what are the prognostics on this one? Dead FET, dead controller, dead back, working perfectly fine. What is it? We see a bit of damage here. Nothing critical, just like something has poked at this ESC, but nothing crazy.
Most common is dead FET, I guess.
Depends on the boards. On SpeedyBees, it would be mostly dead back. Or
That's actually easy to fix, I guess.
yeah. Oh, it's actually, there's either a back, it's a shorted cap usually because it sticks out far, and
Yeah,
it
it gets
just
hit.
tends. Yep, physical damage basically is the most common SpeedyBees, the big SpeedyBees. Right. Let's do the inspection. I'll remove the pigtail actually. So that's also another reason I like doing it on the scope. I think it looks really cool when you see the tin melt, the solder melt. You can see it spread. The meltage spreads. It's much more satisfying than putting your iron in and wait and pulling on it relentlessly till it heats up. Soon, there we go. There we go. All right, let's bring it onto the bench and do some testing. Should be a bit hot. All right, that should be okay. Let me zoom in. Sir FPV asks, following up on the upgrading of the MCU, if the pinout was the same, yes, it would be possible. You would just need to make a target for it. There isn't any. There is some weirdnesses, like for example, F7 doesn't has a way to software invert some UARTs. And that's used by the S-bus pin. S-bus is an inverted signal, so it's probably like I don't know what way it is, but the 1 bit is probably low and the bit 0 is high, so 3.3 volt, or the other way around, while it's the opposite as the UARTs. So on F4 boards, there is a physical inverter on the line that's used for S-bus, and if you were to swap that for F7, because the F7 does software inversion, or at least does it on the chip, then if you were to try to plug in something on that line, it would act inverted. So you would have to do some tinkering with the code somehow to use that line, but you could just not use that. But beside that, if it was the same, which I'm pretty sure it isn't, then you could do it. There's no reason you wouldn't be able to, I don't think. So, checking an ESC. First, we want to see if something's shorted. So I'm going to do plus and minus first. So we are in beep mode. Now, if that's shorted, then we need to find out why. It is not. It's not beeping, so we're good. Now I want to see if any of the motor pads is shorted to either plus or minus. So as I've explained before, there is a FET. So the circuit for each of the motor pads goes plus through a FET to the pad to a FET to the minus. The FET being the field effect transistor, that's the on and off switch that gets triggered in sequence to move the motors. So the FET that's in between plus and the pad is called the high side MOSFET, and the between the minus, the ground, and the pad is called the low side MOSFET. And so by testing continuity between plus and all the pads and minus and all the pads, we test if there's one of them that's shorted. So let's do that. We are looking for a beep. Usually, in my experience, it's rare that you get only the high side shorted or only the low side shorted. Usually you get both, but not always. You get to see all the possibilities in this hobby. Oh. Actually, I can actually check. There is a 600 ohm path somewhere between the pads. So I can actually check. I'm checking on my meter. You can't see it. You'll see it in the next stream or later. And here I can see that this one has it. I thought it does. Yeah, they all have the 600 ohm. So I'm going to check the other side as well. This one doesn't seem to have the 600 ohm path, so I can't check. But the low side MOSFET all had the 600 ohm resistance, so that's promising. And then I can quickly check the body diodes for all the FETs. So that is checking the diode that's in reverse from the FET. So that would be trying to injecting with the red probe on minus and checking the motor pad. And I should have a resistance that's minus is here. Should have a value for. Yeah. So it goes beep because I haven't set the threshold for beeping on that meter. Let me lower that to 0. Actually, do I want it to be? I'll set it to 0.2, and that way you don't get beeps, but I get values. So I'm checking. I'm getting 0.43 volt of voltage drop. I'm checking that all have the same value. That's a way to know if a FET is blown closed. If I get open circuit, open line, then it means the FET is dead. So, but right now I'm seeing 9.43 on all of them. And I'm going to check the other way around. So I'm going to put the minus on the black pen on the black probe on the plus and check if I'm getting all of them. And if that's the case, next step is going to be to power it up and see if it communicates with the flight controller. So we should be able to see from the current draw on my power supply if it's getting any power. Okay, so that's all good. So now we'll need to power it up. So I've got my crocodile clips. Do you guys say crocodile clips or alligator clips? That's a good question. That's very...
In the US, it's alligator.
The gator clips. Let me turn off the PSU so I don't do anything stupid. So here, I'm going to give it, so I'm going to tell you what's happening. I'm going to turn it on, and I'm getting about 0.5 watts of draw, which could be okay if it's a Blue Jay. Usually BL32 draws a bit more. Let's see if we can see under the scope what kind of chip that is. And if I recognize them, because I don't know them all by heart. So here, let me just focus and use the anti-glare light to try to get the perfect reading. Okay, so Fortia here, that's the driver. That's the thing that turns on and off the MOSFETs. And this is G07, I think, a G07 chip. That would be BL32, I think. No, G07. I'm not sure. We'll see if we get motor bips and we'll know. Maybe. It depends. If it's BLS, it hasn't been flashed to Blue Jay, we might not see immediately. But let's see if it communicates. So I'm gonna grab one of the flight controllers we fixed. And I'll take a wire harness and see if we can get, where's the one that we used before? Might have put it back in here. Right, let's give you a bit of a wider view. So here we have ground and bat, and the motor wires in the middle. That's good. What do we have here? Oh, it's one of those wider plugs. Do they tell us? So here, it's interesting to know how to, if you don't know, it's not obvious, but you don't get any sealed screen next to the pins, but you get the sealed screen on the edge. So plus, plus, minus, minus, current sensor, telemetry, and the motors. So we need a white plug, a 10-pin plug. I do have a bunch of them pre-made. Let's see if one fits. So this is one of them, but this one has plus plus the other way. Do we have minus inverted? But the motor's correct on that side. Let's see if the other side fits this. It does not. Do I have one other one that I can try? That's a 10 connected to 10. This one. Nope, same inversion. This one. Nope, same. Yep. I don't think I'm gonna get away with pinning them. So this one has, this one is weird. Let's not do this one. So this one seems to have the plus and minus inverted, and we need to do the other side. The other side has only the plus and minus, so it's going to be pretty quick. Aren't we having fun doing that? Aren't we having fun? So yeah, if people ever ask you, oh wait, how do I connect a flight controller with a ESC that's not from the same brand? Send them a link to my streams, because yeah, I'm gonna be doing it for many streams yet.
Professional repinner.
Yep, pretty much. How's your repair journey going, Mika?
Currently diagnosing an ESC myself.
Nothing. Sorry, you're what? Sorry.
I'm diagnosing an ESC
Oh, you're
right now.
diagnosing an ESC. Yeah. So what are you
And the
seeing?
FETs are okay. So this one seems cool. It's probably the back. Or I'm about to check.
Yeah, I think I'm not. If I start accumulating a number of boards that have one of the what am I going to say? The motor wires, the ESC channels that are bad by like having a motor that spins faster or slower, something like that. If I get a few of them, maybe I'll get a scope and I can start debugging them. So that's ground on the edge. So it's going to be, because it would be cool to see exactly what's happening on the motor pins.
Output. Yeah.
See if I can see, like, if there's a missing phase, for example, something like that. There we go. Should be good. So we have this guy, GND, BAT, and the motors. Oh, yeah. And this has double checking always, so I don't fry some electronics. Plus, minus, and the motor pads, the motors on the end. Yeah. There we go. Now we're gonna give it the juice. Gonna connect this to the PC, and we're gonna do the check for the motors. So motors. So here we have the error. I'm gonna give it juice, and now it's doing the motor beeps, and the error is down to 0. So that's communicating. So I'm gonna put on some motors, and we'll get an idea of what's going wrong. But at the moment, it's working. Let's go overhead. I'll put that away. We don't need this anymore. I wish I had a good solution for all those wires, but I haven't found one yet. Someone has a clever idea. I'm all ears. Keep having wires all over my desk, cluttering. Right. I'll put some gummies on this. Just grab a couple of them. Let me find a few gummies. There you go. Just so it fits on the board a bit more cleanly. I also put a pigtail on before it's easier to test that way. Let's put a third one, even if it's completely broken. No, it's completely broken. Let me grab a third gummy. Gummy. There we go. At least 3 to keep it in the frame. There we go. Now we have to pull the quad. I'll do the pigtail quickly under the scope because it's always fun. I'm not going to do it pretty. I'm just going to do it functional. Yep. Heat it up, heat it up. Can clearly see when when the pad's melting, so it's always nice to have the scope. You can see the flux moving. It's getting there. And yes, on big ESCs, it takes a while to heat up, even with a good iron. There we go, we see it melting together. There's no way around heating up the whole ground pad, so yeah, that's not the prettiest. I would use flux and reflow it normally, but it's perfectly functional for testing. There we go. And I did manage to not get them swapped incorrectly, so all good. And now we undo the work we've done earlier. So one thing you need to always be careful when you're desoldering ESCs is before you release the tweezers, wait for it to solidify, because oftentimes you release it and then it throws balls of solder around and then you have issues. So always wait a second or two before you release the wire. So yeah, how are you guys feeling about this ESC? Is it going to fly perfectly fine? I kind of had a suspicion that it's going to work fine, but I need you guys to send me stuff that's actually proper dead, you know, so I can have interesting streams like we had that one time where I had to do trace repairs. By the way, if you either speak French or don't mind not understanding what's happening, on Thursday, I have another stream, 1 hour earlier than this one, and we're going to be repairing some pads on a camera, on an analog camera. There's a component that got damaged, and it ripped some pads, so I'm going to be doing some trace repairs, and it's going to be super fun, at least for me, because I haven't done many, so it's always a good learning experience. Let's put this out. So if you're interested in pad repairs and don't mind the language, then it's going to be very interesting, I think. This part, when I'm soldering and desoldering motors, is definitely the least interesting part of the stream. Oh, repinning is probably the least interesting, but that's the second one. So if you guys have any questions or anything you want to, any story to tell, feel free. Dav 2112 says 8. I'm not sure what you ate, but hopefully it was good. Am I missing gummy on the ESC? Yes, I am, because I only put 3 because that 3 is enough for it to stay on the test bench. This is just my test bench quad. This, at best, will fly in my workshop for testing, but if I was mounting it in a real quad, I absolutely would put all 4 ESCs. That would also take good care in making sure the spacing between the boards is correct and stuff like that. That's definitely not something you should take example on. I'm just soldering those motors super quickly. My soldering isn't really good here. I'm not using any flux. I'm not making sure it has the right amount of solder to make nice clean joints, but for testing it's more than enough. It's not going to be crushing anywhere. But yeah, trading it quality for speed here, so I don't have you guys wait for me to solder some wires. Yeah, thank you, Dev, for telling me, because I say that this time it was completely intentional to not. I mean, I just found 3 gummies here, but sometimes I manage to solder the wrong wire to the wrong pad and stuff like that, especially on stream when I'm focused on many things. So yeah, absolutely do let me know if you see something done incorrectly. All right, we have a flight controller, we have a thing. Let's see if we get some motor beeps. So I'm gonna put the overcurrent protection back on. So that's the thing that acts as my smoke stopper. And I'll give it 4S, so 16.8 volts. And I'll also plug in the USB, because why not? So I can see stuff. And 3, 2, 1. So that's the beeps that could be BL32 or BL-LES. And I'm getting everything to work. And on the screen share view, you can see that all the telemetry is error went to 0. So it means it is BL-LE32, because BL-LES doesn't do D-shot telemetry. So I'm gonna spin the motors now. And I'm gonna remove the overcurrent protection, and let's spin some motors. And we'll have a look at the number, the RPM number. So everything's spinning, and we are getting very consistent.
Pretty close.
Yeah, I think we're good here. So I'm obviously going to take that off stream to hover and make sure it works. That's since I've been doing repairs, at the start I've had stuff that I repaired that immediately failed or didn't overheated quickly and stuff like that. So I ended up realizing that I needed to actually making sure it at least hovers. There's a limit to things I can do on the bench. I won't be tuning the drone and banging and going for hard flights on everything's repair. So that's why I'm only selling it. I'm only giving them away for $5 because it pays for the parts. But people know that they are taking a risk when they get something that's been repaired by me. I'm no expert. I've been learning that on my own for only a few months. And yeah, so people know that when they're getting the board from me, from the repair box, they're gambling, but they're only gambling five euros. And recently, since I've been doing more tests and making sure it hovers and everything, I've been doing way fewer. I've been getting way fewer people with duds. So it seems to be working pretty good. So yeah, I'm gonna take this one off stream because we're getting on time. So I won't want to bore you with configuring the flight controller and setting up the RX and everything. But yeah, we have a question, I think. Can you show how to calibrate amp draw? I can show you how to calibrate amp draw. There is a few ways you can do it, but the way you should do it at home is it's actually not something I want to show you on the bench because it's something I'm going to have to tell you. It's not something I can do here. What you want to do is you want to calibrate the MAH, basically. It's the same as the amp draw because the amp draw is used to calculate the MAH, that display. So what you want to do is go to your OSD tab and enable the MAH drawn display. And then you want to go and fly a pack. So you charge a pack, you go and fly it, and you write down at the end of that on the flight the MAH drone on your OSD. Then you take that pack and charge it with your charger, charge it to full again, and write down the MAH charged from the charger. And then you do, there's a formula that you can find, and you can find this and also all the things I just told you, but you'll find the formula used to calculate the correct factor. I'll show you where the factor goes, but you can find it in a blog post by Oscar Liang. So go on Google and search for Oscar Liang calibrate amps or calibrate MAH, and you'll find it. And it gives you the formula, but basically in the power and battery tab, there's a thing called, there's a scale somewhere here. That's the, let me show you a screen share actually. There's this number and the scale here. And that's the thing you're gonna be editing by getting, once you have the actual MAH from your charger and the one from your OSD, you can calculate a ratio and you can apply that ratio to that number and you'll get the proper current draw. There you go. Hopefully that was clear. If it was, just come to my Discord and ping me and I'll send you the link to the Oscar Young article. But yeah, it does take flying a pack to calibrate it. All right, I think we are ready to close. So we have a total score for today of 4 repairs, 1 ESC, 3 flight controllers. Only 1 actually needed repairs, the other ones seem to work. They will still need to fly, and possible that we'll find an issue when they fly. It's possible that they were thrown away in anger when the rest of the quad burned, possibly likely because of some thing happening to do with the build rather than the electronics themselves. But we did, you did get to see a swapping the STM chip, so it's always good to see. And if you were interested in saving your electronics, I'm always happy to share anything I can to get you started. The starter pack is a $70 scope, a $50 hot air station, a few tweezers, a decent soldering iron that you probably already have, possibly a fine tip for your iron, and a multimeter. The bench PSU you don't even need because your charger can probably do that for you. Most chargers can act as a PSU, so it doesn't take a lot to start fixing electronics, and it only takes a few saved boards to justify buying it. So yeah. No name says you use OSD charger method. You saw the amp draw was way off on my bench. Yeah, it's nothing's calibrating in what I'm testing. That's none. But yeah, you can, if you wanted to set it on the bench, you can, because that's something I could do now because I do power it from my my PSU, so I can see the amp draw on my PSU, and barring a bit of losses, I could check what I get on the OSD, check what I get on the PSU, and do the ratio and correct the number. That's also a thing you can do, and you can do that using the PSU built in your charger as well. But the MAH method is it's the one that's accessible to everyone. It's also the one that might be more accurate because MAH is an integration over time of the amp draw. So you kind of accumulate small errors. So it kind of gives you a more average value. It means that you're going to get a better calibration. But yeah, you could do it with the amp draw from your PSU, especially if you're confident your PSU has a good meter. Or you could also put your multimeter in line and use that as the amperage meter. So yeah, there are a bunch of different ways. But for this quad, the bench quad, I really couldn't care less about it being accurate in terms of amp draw, especially since the amp draw is not related to the it's related to both. Basically, what determines the amp draw is based on the resistance of the shunt resistor in here and the scaling value that's on the flight controller. And usually, if you use a stack, the value is going to be pretty good for the FC it uses. But if you're using any odd FC on with any odd ESC, it's going to be way off more often than not. So you have to calibrate it. All right, I think I'm going to leave it here. I have a bit of work off stream to test all of that and configure it works. Thank you everyone for coming. Something I always forget to tell you guys, but if you enjoy the stream and learn things or anything like that and want to support me, please leave a comment. It helps a lot. Or like the stream as well. Click the like button. It's really a nice way to make the stream show up for other people. And yeah, it really helps growing the live stream. So also tell your friends if you know people who might be interested in either having that as a chill thing to have in the background while they're doing something else, or actually want to actively start on some electronics repairs. Yeah, just let them know. It's really helpful if you do. All right, I will see you next time and have a good one.